So the good, the bad, and the ugly. I'm going to give you a second to decide who's who in your eyes. So database migration is a very long journey, and part of it, and one of the most hard parts, are the schema and code conversion, and that's what we're going to discuss today. I'm going to start with a bit of an analogy to give you a sense of why this is interesting or why this is hard. So imagine you live in a small town in the middle of nowhere in the Wild West. This town has its own infrastructure, its own rules, its own code of conduct, and you live in this town your entire life. Eventually, you start a business in this town, and you learn whatever you need to know in order to build a business from the ground up, or the infrastructure, all the bolts on how to build a business. And eventually, you actually also hire employees. You teach them the business, you teach them how to operate it, and you even have a steady customer base who rely on your services. As time goes by, your town grows, and as such, your business grows. And suddenly you realize that the cost of operation is too high, whether it's because of taxes or labor or someone requires protection from you. But it's too high to manage. And one day, a railroad is built near your town. And you see that as an opportunity to move your business to a different town while still serving your customer base in the current town. So you research. You go to nearby towns, and you see the potential for growth, the competition there, the cost of operation, and eventually you decide on a specific town to move your business to. But unfortunately, you realize that that town, like any other town, has different code of conduct, different rules, and different language. So what should you do? Should you retrain all your current employees to know how to operate in this new town? Should you rebuild your entire business just to be able to run it on the new town? Whatever you choose, this will be very time-consuming and expensive. And will you be able to serve your current customer base while doing this transition? So this is a very similar problem to what we have today in the database world. Companies, when they started, they chose a specific database to use and build their entire business on top of it. As time went by, their business grew and their database grew, and as such, the cost of running this database grew as well. But as cloud becomes more efficient and the movement to the cloud becomes easier, people saw that as an opportunity to move their databases to the cloud. So they researched the various clouds available and the various databases which they can run on the cloud. And again, they realized that if they do this movement or this migration, they'll have to reevaluate their entire database and even rewrite a significant amount of it. How should they do it? Should they hire locals, meaning hire new engineers who are proficient in the new database? Or should they assimilate, meaning should they train their current employees to operate in the new database? Wouldn't it be great if you had a turnkey solution who would transform your entire database from one place to another? That solution will learn your current database and understand what is the requirements. And according to the database of choice, it will build your entire infrastructure from the ground up. And once the infrastructure is up and running, it will move all the required things you need in order to operate your day-to-day business. And then you can just start running your business in the new database with minimal to no effort on your side. Again, in the database world, this is exactly where database migration tools come into play, and specifically code and schema conversion tools, which allow customers to avoid the current login they're in today. So this is what we're going to talk about. So let's look at database migration project in general. So in each database, you have hundreds to thousands of objects and millions of lines of code. And a migration project is long, and it requires schema and code conversion. You need to move and validate your data. And also, you need to handle the applications which interact with your database. And this is a very costly and long operation. And specifically in this talk, we're going to focus on the schema and code conversion parts of that migration. Just to step back and give a few simple examples why this isn't as simple as one might think. So let's look at two very simple examples of code which resides in the database. So let's assume your database code has the following statement. A space, exclamation mark, space equals space B. So one database will interpret this as A not equals B. However, a different database will interpret the same statement as A factorial equals B. Another example, let's say you have a date literal 10-10-87. One database will interpret that as 10th of October 2087. However, another database interprets the same string as 10th of October 1987. So when you build a code conversion tool, you need to understand all the different nuances in all different databases. And a very interesting question to ask is, did the customer really know these nuances when he wrote the code and accidentally wrote space between the equal or the exclamation mark? So in general, there are three approaches to handle code conversion. You have pattern matching, you have transpilation or compilation, and you have AI/ML-based approaches. We'll dive a bit into each of those now. So pattern matching. Pattern matching is when you look for specific segments of code in the source code, and once you find them, you change that to the equivalent pattern in the target code. This is usually achieved by having a wide array of regular expressions and just run them on the source code until you finish everything. The pros for this approach is that it's easy. You don't need any knowledge expertise or specific domain expertise to write a few regular expressions. And it's very quick to get some ROI out of it because you just write a few regular expressions and you have a code conversion tool ready to run. The cons for this are that this is usually source to target specific, meaning you have regular expressions which match the source code and you have the specific equivalent in the target code. So if you want to scale to more source dialects or more target dialects, that becomes very hard to scale your solution. Yeah, I actually changed this slide, but never mind. So there's like a rule where you can't really levate all the database dialect in regular expressions. You always have holes in your regular expressions because you can't cover everything. And there's no semantic embedding in that solution. What's semantic embedding? Semantic embedding is when you want to give the actual meaning to the statement which is run. A very simple example, let's assume you have A plus B in your code. What does it mean? Is it string concatenation or is it arithmetic addition? If you only do pattern matching, you're not able to understand this and convert it to the right statement in the target dialect. Second approach is transpilation. So in general, compilation is when you take code in one language which have a specific abstraction layer, and you convert it to a language in a lower abstraction layer. Transpilation is when you do the same thing, but you stay in the same abstraction layer. Okay? So in general, there are 4 phases to achieve transpilation or compilation for that sense. You parse the code, you resolve it, you perform semantic embedding, and you emit the code to the target dialect. Let's go over a simple example and show these phases. So let's assume you have this very simple statement, select A plus B from X. The first phase will be to parse the code and create what we call an AST, an abstract syntax tree. The second phase is resolving, where we go over all the identifiers and give them meaning. So we need to know that X is a table and A and B are string columns within that table. The third phase is to perform the semantic embedding phase, meaning now that we know that A and B are strings, we can understand that the plus operator is actually string concatenation. And the last phase, which is emitting, is taking that concrete syntax tree and converting it to code in the target dialect. In this case, in order to concat 2 strings, you have to call the concat function, and you cannot use A plus B. So this is, very generally speaking, the 4 phases of transpilation. The pros for this approach is this is usually source to target agnostic, because you first compile your code from the source dialect to some form of intermediate representation, like we saw here in the AST. And then you emit the code from that intermediate representation to a target dialect. So it's easier to add more sources and more targets because you reuse each part over and over again. As we saw, we can do semantic embedding. And because we go over the entire code and compile it, we're able to give much more accurate reporting on the solution. The cons are that it's very hard to write a good transpiler or compiler. And like in compilation, it has a higher blast radius than just mismatching a specific statement. So if you fail to parse a specific part of the file, you might stop the compilation of the entire file. Last is AI/ML. So as we might expect, as code conversion capabilities or code generation capabilities increase using AI/ML, whether it's GitHub Copilot or Amazon Whisper, so you would assume that you can build a model which allows you to automatically convert from one dialect to another dialect. The pros for this is that you can build a model and you don't have to have all the data yourself. You can base your model on top of open source code which is available and build a huge corpus. And since this can be done automatically, your model can adapt and change over time, whether you get more and more examples or new releases or versions are released. The cons for this is, in order for this model to work well, you need to have a huge corpus of data. And sadly, there are not a lot of good or even any examples for converting SQL dialect from one to another. So it's very hard to achieve or find this corpus. Usually, the results are not entirely predictable, so it's hard to build a solution which doesn't require any user intervention while converting the code from one dialect to another. And like in the first approach, this is usually source to target specific, meaning you train your model on specifically converting from a specific dialect to a specific dialect. And not all models can be generalized to support multiple dialects. Go.
5 minutes.
5 minutes. Great. Conclusion. So in databases, as in businesses, you usually start small with certain assumptions, and as time goes by, your business grows and the landscape might change. Once that happens, you might want to move your business or your database to a different place, and this migration process is long, expensive, hard, and time-consuming. Should I start from the beginning? So the bad news are that it's hard to do this code conversion in a good way. There are a lot of different dialects, each with its own nuances, as we saw in the examples. And not all these capabilities are documented. And even if they are documented, the documentation is usually wrong or not complete. The ugly part is that there's a long tail of capabilities for each database. So you can never cover everything. You can't do 100% automatic conversion, which touches the second point of the ugly part is that you need to manage customer expectations. When a customer wants to pay for the service or they come for you for the service, they expect you to take care of their entire database migration. But then you need to manage their expectations that they have to do some manual work on their own. The good news is that it's a huge market and there's a significant demand for this in the market. Since this is a very hard and unsolvable problem, it's a very good place for innovation and new approaches. And we in Google DMS are combining all three approaches to bring the best-in-breed solution for the market. Thank you very much.